Okay, hello everyone. Let's go ahead and take a look at a particular function that we'll look at next called the modulus function. Now, by definition, the modulus function of a real number is its distance from zero on the number line. You've often seen this just written as the absolute value function or the absolute value of x. And another interpretation of the absolute value of x is going to be the square root of x squared. Okay, now there are a couple of important properties, assuming that a is greater than 0, of this modulus function, so that whenever we come across the modulus function in either inequality or equality, in an equation or an inequality, then we know we can go ahead and quickly solve for them just by using these properties. So, notice that it says that if x, absolute value of x is equal to a, then x is going to be equal to plus or minus a. If absolute value of x is less than a, then negative a is less than x is less than a. If the absolute value of x is greater than a, then we have x is less than negative a or x is greater than a. And if absolute value of x is equal to the absolute value of a, then x is going to be the absolute value of x is going to be equal to plus or minus a. Okay, so let's go ahead and take a look at these first 1, 2, and 3 and just use an example to show you exactly how we can use these properties to solve for equations or inequalities involving the modulus function. So say for example we have the absolute value of 3 minus 4x is equal to 2. Now if we go ahead and use this first property here, notice it says that if that's true, then x has to be equal to plus or minus a. So this part right over here, which would be considered the x, has to be equal to 2, or that has to be equal to negative 2. Now that should make sense if you just go ahead and consider. Now if we're letting that be equal to 2 and I substitute that for 2, the absolute value of 2 is 2. Or if we set that equal to negative 2, then the absolute value of negative 2 is 2. And so both of those equations make sense. So now I can just go ahead and solve these, being that they no longer involve the modulus function, and I would solve normally. Just subtract 3, divide by negative 4, subtract 3, divide by negative 4, and I know that I would come out with x is equal to 1/4 or x is equal to 5/4. Now if I went ahead and changed this from an equality to an inequality, and in this case let's say greater than 2, then I need to use this one. It says if the absolute value of x is greater than a, then x is going to be less than negative a, or x is going to be greater than a itself. So here we go. Let's go ahead and say then that this part right over here is going to be greater than 2, because if this is greater than 2, then anything that I put into here, the absolute value will also be greater than 2. And in the same respect, if this is less than negative 2, then if I put any number here that's less than negative 2, if I take the absolute value, of course that is also going to be greater than 2. So again, that makes sense. So now that I no longer have the modulus function in here, I just solve these inequalities. The one thing to just be careful of is that if you go ahead and multiply if you multiply both sides or divide both sides by a negative number, and in this case we're dividing both sides by negative 4, you have to switch the direction of the inequality sign. So what I have then is x is less than 1/4 or x is greater than 5/4. Okay, and let's take a look at the last situation here, which is C. It says, what if you have the absolute value of 3 minus 4x being less than, the absolute value of that being less than 2? Now what that means then is that this part has to be either greater than negative 2, right? Greater than negative 2, because if it's greater than negative 2, then it's, say for example, negative 1 or 0, then the absolute value of that will still be less than 2. And it also has to be less than 2, so that if this number here is, say for example, 0.5, that number there is 0.5, then it's still going to be less than 2. So again, that equation here, or this property, makes sense. Now, the way that you actually go about solving this is just a little bit different in just its format. Okay, we can just go ahead and solve in order to solve for x, we just subtract 3 from all 3 sides. So instead of just having a left and a right hand side, we actually have a left, a right, and a center. But we still have to do the same thing. We have to subtract 3 from all different areas, from all 3 different areas. And then after that, we come up with negative 5 is less than negative 4x is less than negative 1. And again, we do the same thing to all 3 of the parts, left, the center, and the right. And we divide both by all 3 by negative 4. And remember, because we've divided by a negative number, we have to switch the inequality sign so that it says 5/4 greater than x greater than 1/4. Now, one thing that's going to be nice about this as well, say for example, if you forgot to switch the signs, what you would have come up with is 5/4 is less than x, which is less than 1/4. And hopefully that does, to you, that should ring a bell. And that doesn't make sense because 5/4 is actually greater than 1/4. And the transitive property has to be true for that solution to actually make sense. Okay, so that's what we're going to do next, is we're going to take a look at the modulus function and make sure that we can actually use these important properties to be able to solve for equations that involve the absolute value. Okay, well, we'll see how you do. See you next time. Goodbye.